Now we reach dead stars. A star lives by balance. Gravity pulls inward while fusion pushes outward. For millions or billions of years, those two forces can hold each other in place. Then the fuel changes. Pressure shifts. Balance fails. What happens next depends on mass. A smaller star may fade into a white dwarf. A massive star can explode. An even denser remnant may become a neutron star. The most extreme collapse can lead to a black hole. A white dwarf is the exposed core of a dead star. It can contain a mass close to the sun packed into a body roughly the size of Earth. Matter there is crushed into a form far denser than normal rock or metal. A teaspoon of white dwarf material would be unimaginably heavy. Think less of a brick and more of a mountain packed into a spoon. Neutron stars go further. They are what can remain after a massive star explodes and collapses. Matter becomes so compressed that atoms can no longer survive in the usual way. Electrons and protons are forced together. The result is a city-sized object with more mass than the sun. Picture the sun crushed into something small enough to fit near a city. That is not a normal object. It is a warning that matter has hidden forms. Under enough pressure, the familiar world disappears. Some neutron stars spin many times each second. These are pulsars. Their beams sweep through space like lighthouse signals. When the beam crosses Earth, radio telescopes detect pulses. The rhythm can be incredibly precise. A dead star can become one of the most accurate clocks in the universe. An exploded star leaves behind a spinning remnant, and the remnant keeps time. Some neutron stars have magnetic fields so strong they become magnetars. A magnetar's magnetic field is beyond anything found on Earth. Too close, and ordinary matter would be in serious trouble. Atoms themselves would be affected. This is not a monster from fiction. It is a possible ending for a real star. The universe makes objects that sound invented because normal life gives us no comparison for them. A mountain is not enough. A bomb is not enough. A storm is not enough. The scale is different, so familiar words keep failing. A neutron star is not just dense. A black hole is not just dark. A supernova is not just an explosion. Each one is a place where ordinary language runs out of oxygen. Another strange fact hides inside every body on Earth. You are made of star remains. Carbon in your body was formed through stellar processes. Oxygen was shaped in cosmic furnaces. Iron in your blood is connected to violent stellar history. Calcium in your bones did not begin on Earth. Our planet inherited material from earlier generations of stars. Your body is not separate from the universe. It is processed universe. Ancient stars lived, changed, exploded, and spread atoms into space. Those atoms mixed into new clouds. Clouds formed the sun, planets, oceans, rocks, and eventually living bodies. The universe did not only create a place where you exist, it became the material you are using to exist. This is not poetry. It is chemistry with a very long backstory. Every breath carries atoms older than the planet. Every heartbeat uses elements made before there were humans, trees, cities, or language. A person looking at the stars is made from earlier stars looking back through biology. The idea is beautiful, but it is also strange. Death at one scale becomes construction at another. A star dies, a planet forms, a body grows, and a mind begins asking questions. Cosmic recycling is not gentle. It includes collapse, impact, radiation, shock waves, and fire. From that violence came rain, skin, leaves, eyes, and eventually sleep. The universe can be brutal and delicate at the same time. Now follow those atoms into the solar system. Earth feels normal because it is home. The rest of our neighborhood quickly proves that normal is only local. Venus is farther from the sun than Mercury, but it is hotter. A thick atmosphere traps heat so brutally that the surface can melt lead. Mercury sits closer to the Sun, yet its nights can become extremely cold because it has almost no atmosphere to hold warmth. Distance matters, but atmosphere can change the story completely. A planet is not just a rock in an orbit. It is a pressure system, a heat engine, a chemical machine, and sometimes a trap. Mars looks quiet now, but it carries the scars of a more dramatic past. Its volcano, Olympus Mons, rises higher than any mountain on Earth. Its canyons stretch so wide that they make human landscapes feel tiny. Ancient riverbeds suggest water once moved across the surface. Today, the planet is cold, dry, dusty, and thin-aired. A world can keep the shape of its past long after the past is gone. Jupiter is so large that it could hold more than 1,000 Earths by volume. Its great red spot is a storm larger than our planet, although it has been changing over time. That storm is not a passing cloud. It is a planetary wound in motion. Winds, pressure, chemistry, and heat have turned Jupiter's atmosphere into a moving painting with no solid ground beneath it. Near Jupiter, moons become worlds of their own. Europa may hide an ocean beneath ice. Ganymede is larger than Mercury. Io is covered with active volcanoes because Jupiter's gravity needs it from the inside. A moon does not have to be small and dead. In the right orbit, a moon can be one of the most extreme places in the solar system. Saturn looks peaceful because its rings are beautiful. The rings are not solid bands. They are made of countless icy pieces, from tiny grains to larger chunks, all orbiting at different speeds. From far away, they look smooth. Up close, they would be a vast swarm of frozen fragments. Beauty in space is often made from debris. Saturn's moon Titan is stranger than many planets. It has rivers, lakes, clouds, rain, and seas. The liquid is not water. Methane and ethane flow across its surface under a thick orange atmosphere. Titan is almost Earth-like in shape, but alien in chemistry. It reminds us that familiar patterns can be built from unfamiliar ingredients. Uranus rolls around the Sun on its side. Its axis is tilted so extremely that its seasons become bizarre. One pole can face the Sun for decades, while the other remains in darkness. A giant impact long ago may have knocked the planet into this strange position. Even a planet's posture can carry the memory of violence. Neptune is far from the Sun, but it has some of the fastest winds in the solar system. Cold distance does not mean calm. Energy can hide inside a planet and still drive violent weather. Pluto, once treated like a frozen dot, turned out to have mountains made of water ice and plains of nitrogen ice. At those temperatures, water ice behaves more like rock. A substance that melts in your hand can build mountains at the edge of the solar system. Comets are ancient leftovers. They carry ice, dust, and material from the early solar system. When a comet nears the Sun, frozen gases wake up and create a glowing coma and tail. That tail does not simply trail behind like smoke from a plane. It points away from the Sun, pushed by radiation and solar wind. Even a comet's tail is a signpost showing where the Sun is. Asteroids can have moons. Small rocks can orbit larger rocks. Gravity does not care whether an object looks impressive. If there is mass, there is pull. Some asteroids are rubble piles held together by weak gravity. Others are metal-rich fragments from the cores of destroyed young worlds. A small stone in space can be a broken piece of a planet that never became a planet. Meteor showers are not stars falling. They are tiny pieces of debris burning in Earth's atmosphere. Many are smaller than pebbles. Speed turns them into light. A grain of cosmic dust can enter the sky fast enough to become a bright streak. The solar system has borders, but not walls. The Sun blows a stream of charged particles outward, forming a vast bubble called the heliosphere. Beyond that region, interstellar space begins. Voyager spacecraft have crossed into that distant environment, carrying human-made machines into the space between stars. They are moving through darkness with old instructions, tiny power, and no possibility of returning. Even interstellar space is not truly empty. It contains thin gas, dust, magnetic fields, and cosmic rays. Compared with air on Earth, it is almost nothing. Across light years, almost nothing still becomes something. A single particle in a small box would seem empty. Stretch that box across the galaxy, and the few particles begin to matter. A true vacuum is not truly nothing either. Quantum fields still exist. Particles can appear and vanish in ways ordinary life does not prepare us to picture. Empty space is not a blank stage. It has rules, energy, structure, and behavior. The universe can look empty while still being active. Space also has a temperature. The cosmic microwave background leaves deep space at about 2.7 degrees above absolute zero. That is incredibly cold. It is not perfect zero. Even the dark carries leftover heat from the beginning. Cold space is not the absence of history. It is history cooled almost all the way down. Sound cannot travel through empty space the way it travels through air. A distant explosion in vacuum would not boom across space to your ears. There are too few particles to carry ordinary sound waves. Movies fill space with noise because silence feels unnatural. Reality would be more eerie. A flash could happen without a roar. Yet planets and stars do make signals. Jupiter produces radio emissions. The sun sends out storms of particles. Pulsars flash in radio beams. Scientists can convert some space signals into audio, but those are translations, not normal sounds traveling through air. The universe is not silent to instruments. It is silent only to ears like ours. The sun has weather. Solar flares, coronal mass ejections, sunspots, and magnetic storms can affect Earth. Satellites can be disrupted. Radio communication can be disturbed. Power grids can feel the shock. A storm on the sun can touch technology on Earth without ever touching the ground. Auroras are visible proof that Earth is connected to space. Charged particles follow magnetic field lines toward the poles and strike gases in the atmosphere. The glow can look soft and dreamlike. Behind that beauty is a planet-sized shield interacting with a star. Earth's magnetic field is not decoration. It helps protect our atmosphere and surface from some charged particles. Mars has no strong global magnetic shield today. Over time, its atmosphere became thin. A planet can lose its air. Habitability is not only about water or distance from a star. It is also about whether a world can keep its sky. The moon is slowly moving away from Earth. Only a few centimeters each year, but the motion adds up across deep time. Long ago, the moon was closer. Earth spun faster. Days were shorter. The familiar 24-hour day is not permanent. Even timekeeping on Earth is part of a changing gravitational relationship. A day on Venus is longer than its year. The planet rotates so slowly that it orbits the sun faster than it spins once. Even stranger, Venus rotates backward compared with most planets. If you could stand on Venus and see through the clouds, the sun would rise in the west and set in the east. A planet can rewrite the most basic idea of morning. Time itself is not the same everywhere. Gravity and speed both change how clocks tick. Atomic clocks can measure tiny differences between Earth and orbit. GPS satellites must account for relativity, or navigation would slowly become wrong. This means modern phones depend on corrections from Einstein's universe. Relativity is not locked in a textbook. It is quietly helping maps work. Astronauts age slightly differently from people on Earth. The difference is tiny for current missions. Still, it is real. Traveling through space changes not only location, it changes the rate of time. The fastest human-made spacecraft are still slow compared with the distance to the stars. A probe can cross the solar system and still be nowhere near another star. Proxima Centauri is the nearest known star to the Sun. Yet its light takes more than 4 years to reach us. Human speed feels impressive until the galaxy becomes the measuring stick. The Milky Way is not a still disk. It rotates, warps, absorbs smaller galaxies, and carries our solar system around its center. Earth rotates under your feet. Our planet orbits the Sun. The Sun orbits the Milky Way. That galaxy moves within the local group. Larger cosmic structures carry the local group too. Even when you are lying completely still, you are traveling through space in several ways at once. Stillness is local. Motion is cosmic. The Sun takes hundreds of millions of years to orbit the galaxy once. One galactic year is longer than the entire history of humanity. Dinosaurs lived under a sky where the Sun was in a very different part of its galactic path. Our solar system has been moving through the Milky Way since long before humans appeared. A night on Earth feels familiar because our lives are short. On the galaxy's clock, we are a brief flicker. The Milky Way itself is also not alone. Andromeda is moving toward us. In several billion years, the two galaxies are expected to merge. Stars probably will not smash into each other often because the distances between them are huge. The galaxies will still reshape each other. Gas clouds will collide. Star formation may ignite. The sky would become unrecognizable from any world still watching. A galaxy collision is not like two cars hitting. It is more like two ghostly cities passing through each other while gravity rearranges every street. The stars are far apart. Gravity is not. Over time, separate spiral galaxies can become one larger system. Even galaxies have life stories. They are born, grow, merge, feed, and fade. Some become giants by swallowing smaller galaxies. The Milky Way carries signs of past meals. Streams of stars around it are clues from galaxies it absorbed long ago. The sky above us has a history of cosmic violence hidden behind its calm appearance. A peaceful-looking galaxy may be built from old collisions. Now zoom out even more. Galaxies are not spread evenly like sugar on a table. They form a cosmic web. Long filaments connect clusters. Huge voids open between them. Dark matter appears to help shape this pattern. The universe, at the largest scale, looks less like scattered dots and more like glowing threads around dark gaps. Some voids are enormous. They are not completely empty, but they contain far fewer galaxies than average. Imagine a region of space so wide that whole galaxies become rare. A civilization inside such a void might see a darker night sky. Its astronomers might discover the larger universe much later. Location matters, even in space. Some neighborhoods are crowded, others are lonely. Galaxy clusters are among the largest structures held together by gravity. They can contain hundreds or thousands of galaxies. Between those galaxies is hot gas. Around and through the cluster is dark matter. The visible galaxies may be only the shining beads in a much larger invisible structure. Again, the universe repeats its favorite trick. The bright part distracts us, while the hidden part controls the motion. The same pattern appears in galaxies, in clusters, and finally in the universe as a whole. What we see is real. It is simply not the full story. Now the question changes. If the universe is this large, this old, and filled with so many stars and planets, where is everyone? That question has a name: the Fermi paradox. It asks why, in a universe with so many possible worlds, we do not see obvious signs of alien civilizations. The silence is strange. Maybe life is rare. Perhaps simple life is common, but intelligence is rare. Another possibility is darker. Civilizations may not last long enough to spread or be heard. Signals may be too weak. Distances may be too large. Timing may be the real wall. Two civilizations could live in the same galaxy and still miss each other by millions of years. Imagine sending one radio message into the dark. It spreads, it weakens, It crosses empty space. By the time it reaches a distant star, it may be almost impossible to separate from noise. The universe may not be silent because nothing is there. Distance might be an ocean larger than any signal. Earth could also be rare. That possibility is both thrilling and lonely. We cannot honestly say life is rare, and we cannot honestly say it is common. Right now, the only accurate answer is that we still do not know. For now, every telescope has found planets, chemistry, dust, stars, water clues, and extreme worlds. No confirmed alien city has answered us. No clear artificial signal has changed everything. No unmistakable message has crossed the dark and stayed undeniable. The sky is full of places. So far, it has not answered back. That silence may be the strangest fact of all. The universe is not empty. Stars are everywhere. Planets may be everywhere too. Chemistry is spread across dust, ice, oceans, atmospheres, and darkness. Yet as far as we know, every voice in the universe is still coming from one planet, under one atmosphere, around one ordinary star. For tonight, that is enough to make the familiar world feel impossible. You are not sleeping under a simple sky. Above you are ancient light, hidden matter, dead stars, invisible gravity, unreachable galaxies, possible ocean moons, rogue planets, and questions older than history. The universe is not far away in the way we usually imagine. Its atoms are in your body. Its light is in your eyes. Its gravity is under every step. Its past is still arriving from the dark, and somewhere beyond what we can see, the rest of reality continues without waiting for us to understand it. So let the sky feel large tonight. Let the dark stay strange. Let the questions remain open. The universe has been expanding for billions of years before this moment. It will not run out of mysteries before morning. Most of reality is invisible. Every star, planet, ocean, mountain, animal, and human body belongs to the small part of the universe that actually lights up. Scientists know the rest is there because galaxies move as if invisible weight is wrapped around them. Even stranger, some galaxies we can see tonight may already be beyond any journey we could ever make. Their light reached us, but we could never reach them back. Your body is made from atoms older than Earth. Above you, ancient light is still arriving from a time before the sun existed. Around you, space looks empty, but it is carrying radiation, particles, gravity, magnetic fields, dust, and signals from dead stars. Inside the dark are planets without suns, moons with buried oceans, stars that have already died, black holes that bend time, and galaxies that are slowly disappearing from our future. Tonight, that is where this journey begins. The universe is not only large, it is delayed, hidden, expanding, bending, burning, freezing, collapsing, and quietly carrying old light through the dark. So the real question is not only what is out there, maybe the better question is this: how much of reality has been sitting in front of us the whole time, completely unseen? Start with the first strange fact. The universe is not mostly made of stars. That sounds wrong because stars are the things that glow. Galaxies look enormous because they shine, but shining matter is only the bright skin of a much darker body. Dark matter does not glow, reflect, burn, or form beautiful worlds that telescopes can easily photograph. Gravity gives it away. Astronomers watch galaxies spin, and the motion does not match the amount of visible matter inside them. Something unseen appears to add weight. Imagine a carousel spinning at night, with only a few horses covered in lights. The dark horses are still attached, because the whole machine moves as if they are there. Galaxies create a similar problem. Scientists see the glowing stars, gas, and dust, but the galaxy behaves as if more mass is hiding around it. A galaxy should fly apart if the visible parts are all it has. Instead, the stars keep moving as if an invisible structure is holding the system together. Dark matter may not shine, but its fingerprints are everywhere. Another strange fact is even bigger. Dark matter is not the largest hidden part of the universe. Dark energy appears to make up even more. Rather than holding galaxies together, it is linked to the expansion of space itself. Distant galaxies are not simply flying away like sparks from a fire. Space between them is stretching. Picture raisins inside rising bread dough. Those raisins are not crawling through the dough. Distance grows because the dough itself expands. Galaxies behave a little like that on the largest scales. Across small distances, gravity can still win. Across enormous distances, expansion becomes the larger story. This leads to one of the most uncomfortable facts in cosmology. Some galaxies can move away from us faster than light without breaking the speed limit. Nothing nearby is racing through space faster than light. Space itself is stretching between us and them. A car cannot outrun the fastest car in the world. However, if the road underneath keeps stretching faster than the car can drive, the destination still gets farther away. That is the loophole. Light has a speed limit. Expanding space is not a normal road. Because of this, some galaxies we can see tonight are already unreachable. Their light left long ago, crossed the dark, and arrived here. A future spacecraft could chase those galaxies forever and still never arrive. Expansion would keep lengthening the road. Seeing something in the universe does not always mean reaching it is possible. A galaxy can be visible and already lost. Another strange fact breaks the picture most people carry in their heads. The universe has no known center. That feels wrong because every explosion we know has a center. A bomb starts from one place. Fireworks spread outward from a point. Broken glass flies away from where it hits the floor. The Big Bang was not like that. It did not explode into a dark, empty room. Space itself expanded. Everywhere was closer together. Every direction was once hotter, denser, and more compressed. Asking where the Big Bang happened is like asking where the surface of Earth begins. There is no special dot on a globe where the whole surface secretly starts. The surface is everywhere. In a similar way, the early universe was not sitting inside space. Space was part of the thing changing. Earth is not at the center, neither is the sun. Our galaxy is not sitting in the middle of the cosmic stage. From almost any distant galaxy, the rest of the universe would also appear to be moving away. Every observer can feel central without being the true center. That single idea quietly breaks the human picture of reality. Now look at the night sky. Darkness above you is not nothing. It is evidence. Night is dark because the universe had a beginning, because light takes time, and because space has been stretching that light for billions of years. If the universe were eternal, endless, and filled with stars forever, the sky might not be black. Every direction could eventually land on a star. Instead, most of the sky is dark. That darkness tells us stars have not been shining forever. Light has limits. Even the black sky is carrying information. The oldest light we can detect is not ordinary starlight. It is the cosmic microwave background. This is the leftover glow from the early universe. Human eyes cannot see it. Radio instruments can. That glow comes from a time when the universe finally became transparent. Before then, light was trapped. Matter was too hot and crowded. Photons bounced around like headlights stuck in thick fog. Eventually, the universe cooled enough for atoms to form. Light escaped. Ancient radiation began traveling through space. Today, that same early glow still arrives from every direction. When scientists measure the cosmic microwave background, they are not looking at a normal object. They are seeing the baby picture of the universe. Not a symbolic picture, a real afterglow, a fossil made of light. Here is the part that should not feel real. That light started traveling before Earth existed. The signal is older than the sun. It is older than the Milky Way's present shape. A faint microwave glow in the sky is older than every ocean, every mountain, every fossil, and every living thing on this planet. Still, it is arriving now. From every direction, the early universe is quietly reaching us. Ordinary starlight is also stranger than it looks. When you look at the moon, you see it as it was a little more than 1 second ago. Sunlight shows the sun from about 8 minutes ago. A star 10 light years away is seen as it was 10 years ago. One galaxy a billion light years away is not just far away, it is 1 billion years in the past. Telescopes do not only look across space, they look backward through time. Every deep image of the universe is also an old photograph. Some stars in the sky may already be dead. Their light can keep traveling long after the star has changed, collapsed, or exploded. A bright point above you might be an old message from something that no longer exists in that form. Space does not update instantly. It sends news at the speed of light. Imagine seeing a lamp across a valley. The lamp goes out, but for a short moment your eyes still see it burning because the final light is still traveling. Cosmic distance works like that, except the valley can be thousands, millions, or billions of light years wide. A star can die, and the sky can keep its memory. Nothing in astronomy is truly live. The moon is slightly delayed. Sunlight is delayed. Distant galaxies are ancient delayed images stretched across the dark. Even the present moment depends on how far away you are looking. Now move closer to home. Our sun feels steady because human life is short. On a cosmic clock, the sun is changing every second. Deep inside it, hydrogen is being turned into helium. That process releases the energy that becomes sunlight. This is not fire. Fire needs chemistry. The sun shines because matter is being fused under extreme pressure. Every sunrise is powered by nuclear fusion. Every shadow on Earth exists because atoms are being changed inside a star. The sunlight touching your skin did not begin at the surface. Energy made in the core had to work its way outward through dense solar material. After it finally escaped, it crossed space in about 8 minutes. A photon can spend an incredibly long time trapped inside the sun, then reach Earth during a coffee break. That is a strange kind of patience. The sun is also losing mass every second. Some mass becomes energy. Solar wind carries material away. Compared with the total mass of the sun, the loss is tiny. Still, the spending never stops. Our star is slowly paying itself out as light. One day, the easy fuel that keeps it stable will change. The sun will not explode like a giant star. Instead, it will swell. Mercury may be swallowed. Venus will face disaster. Earth's future becomes uncertain, but it will not remain the quiet blue world we know. A star that feels gentle now will eventually become enormous. That is the trap of living beside a stable star. Stability is temporary. On the largest clock, everything evolves. The sun is not special because it lasts forever. It is special because it lasts long enough. Long enough for planets to cool. Long enough for oceans to form. Long enough for life to crawl, swim, walk, build, and look back at the star that made it possible. Yet the sun is only one star. The Milky Way contains hundreds of billions. Some stars are smaller and redder. Others are hotter and blue. Color is not decoration. It is temperature made visible. Blue stars burn hotter and usually live shorter lives. Red stars are cooler and can last far longer. The universe's most common stars are not like the sun. They are red dwarfs, small, dim, and long-lived. Some may shine for trillions of years. That means the far future of the universe may belong mostly to tiny red stars, not giant bright ones. A red dwarf can live so long that the current age of the universe looks like childhood beside it. Yet living near one would not be simple. A planet must orbit close to receive enough warmth. Close orbits can lock a planet's rotation. One side may always face the star, the other side may stay in permanent night. Imagine a world where sunrise never moves. One hemisphere sits under endless daylight, another freezes under permanent darkness. Between them, a ring of twilight might be the safest place to stand. That sounds like fantasy, but physics can allow it. Some alien worlds may not have days like ours. Others may not have years we would recognize. A planet close to its star can orbit in days. Another far away may take centuries. Time on a planet is not universal. A birthday is just one lap around a star. Change the star, change the orbit, and age becomes a local habit. Now consider planets without any star at all. Rogue planets drift through space alone. They may have been thrown out of their original systems by gravity. No sunrise waits for them. No sunset closes the day. A world can move through interstellar darkness with no warm parent star. Some rogue planets might still hold internal heat. Others could have thick atmospheres or frozen oceans. A planet does not need daylight to exist. It only needs mass, gravity, and a history. That idea is deeply strange, because we are used to worlds as members of solar systems. The universe may contain countless planets traveling alone. Most would be invisible to ordinary eyes. Many could be cold, dark, and almost impossible to find. There may be more planets than stars. Thousands of exoplanets have already been confirmed, and the real number is likely much larger. Our solar system is not the template. It is one example. Other systems contain giant planets close to their stars. Some have planets orbiting two suns. Others may hold worlds covered in deep oceans. A few may have atmospheres where the weather sounds impossible. On one distant world, scientists have suggested glass-like particles could be blown through the sky by fierce winds. This would not be gentle rain. It would be mineral weather moving sideways through an alien atmosphere. Earth weather is water in motion. Alien weather can be chemistry in motion. Rain does not have to be water. Clouds do not have to be white. Skies do not have to be blue. A planet is a machine made from gravity, heat, chemistry, and time. Change the ingredients, and the machine becomes strange. Some worlds are so close to their stars that their atmospheres are being stripped away. Others are puffed up like overheated gas balloons. A giant planet can become larger than Jupiter, but surprisingly light for its size. Heat can swell it. Radiation can distort it. Gravity can stretch it. The word planet sounds familiar, but the universe uses that word for many different things. Now return to black holes. Nothing in space has a worse public image. People imagine them as cosmic vacuum cleaners. That image is not quite right. A black hole does not suck in the whole universe. From far away, its gravity behaves like the gravity of any object with the same mass. If the sun somehow became a black hole with the same mass, Earth would not instantly fall in. The orbit would remain almost the same. Life would end because sunlight disappeared, not because Earth was swallowed. Danger begins when something gets too close. Near the event horizon, escape becomes impossible. The event horizon is not a metal surface. It is a boundary in space-time. Cross it, and every possible road points inward. Even a beam of light has no exit left. That is why a black hole is black. Not because it is painted dark, because the future inside it leads deeper. Time also changes near a black hole. A distant observer watching something fall toward the event horizon would see it slow, dim, and redden. The falling object would experience time differently. Gravity is not just a pull. It also changes the shape of time. Inside the event horizon, escape is no longer one of the available paths. The map of reality has changed. Black holes can also shine without shining. The black hole itself emits no visible light from inside the event horizon. Material around it can become extremely bright. Gas spiraling inward heats up. Friction, magnetic fields, and gravity turn the surrounding region into a glowing disk. Some of the brightest objects in the universe are powered by black holes. The darkest centers can create the brightest neighborhoods. A quasar can outshine an entire galaxy. Its engine is a supermassive black hole feeding on material. The light does not come from the hole. It comes from matter heating, tearing, and glowing before it disappears. Destruction becomes brightness. At the center of the Milky Way, there is a supermassive black hole. It is called Sagittarius A star. Stars near it orbit quickly, pulled by an enormous invisible mass. We do not see that black hole like a planet. We see what gravity does around it. The universe often reveals hidden things this way. Dark matter works through motion. Black holes work through orbiting stars and hot gas. Exoplanets can reveal themselves when a star wobbles or its light dips. Something unseen leaves a pattern. Science often begins with the pattern, not the object. Gravity itself has another strange ability. It can bend light. That sounds impossible because light has no ordinary weight. Yet light follows the shape of space-time. Mass curves that shape. A galaxy can act like a lens. A cluster of galaxies can stretch and magnify the light of something behind it. The universe can use gravity as glass. Sometimes a distant galaxy appears as an arc. Other times, the same background object can appear in multiple places. There are not several copies of the galaxy. Light has taken different curved paths around a massive object. Imagine looking at one candle through warped glass. The candle is single, but the image breaks into many shapes. Gravity can do that on a cosmic scale. This is called gravitational lensing. It lets astronomers see deeper than they could otherwise. A massive galaxy cluster can become a natural telescope. The universe bends its own light to show us more of itself. Light bends, time stretches, space expands, matter hides, and stars can die while still shining across our sky. Already, the real universe is stranger than most invented ones.